Now we get to variable stars, page 69. This is one of the reasons why it's so important to understand how stars work, because variable stars are the first standard candles. Standard candles are what astronomers use to measure enormous astronomical distances, all right? And the first standard candle that we became aware of was something called a variable star. What are variable stars? Well, they are mature core helium fusion stars. Now we understand what these are, that vary in luminosity in regular periods of cycles that range from a few days to a few months. Okay. Number two, in these particular types of stars, there is a strong direct relationship between period and luminosity. Okay, so go ahead and write that in. Number two, strong direct relationship between period and luminosity. The period luminosity relationship is roughly this. Okay, very simply, the longer the period, the brighter the peak luminosity. This period luminosity relationship was discovered by Henrietta Leavitt in 1908. Okay, now, before I press on, I got to talk a little bit about Henrietta Leavitt. Okay, so discovered by Henrietta Leavitt in 1908, working at the Harvard Observatory. Her work was published in 1912. This was before women could vote in this country. Henrietta Leavitt was the first woman, if you can believe this, she was the first woman to work at the to be permitted to work at the Harvard Observatory unsupervised by a man. Believe it or don't, but those were the times that she lived in. Okay, So Henrietta Leavitt was looking over photographic plates of these stars that seemed to be varying. And so as time went on, she was able to establish this very distinct, very measurable, very predictable relationship between the period of a variable star's cycle and its peak luminosity. This allowed astronomers to use it as a standard candle. Now, when we talk about a standard candle, the basic idea of a standard candle is this. It's just like looking at headlights on the highway. You can tell roughly by how bright those headlights are whether the approaching vehicle is close or far. Well, imagine being able to measure that brightness precisely and establish a relationship between its brightness and its distance. Okay, this will be a bit of math that we'll be getting into down the road here, something called the distance luminosity modulus. But this is essentially what the idea of a standard candle is. If we know what the peak luminosity of an object is, and we can measure it, then we can determine its distance. This is the tool that Henrietta Leavitt gave 20th century astronomers that they did not have before. Recall, up to this point, the only way that we could measure distances was the parallax method from Tycho Brahe. And recall also that parallax method is good for within the solar system, but anything beyond that, not so much. Now, one caveat I will add to that is nowadays, with extremely precise instrumentation that's available to us in this wonderful digital world, we are revisiting the idea of using parallax to measure great distances, but that's only because the technology has gotten to a point where we can do that. But that wasn't the case back in 1908, all right? So we had no way of measuring distances outside our solar system until now. This is huge. So number 5, it's an important standard candle. And this standard candle is used in galactic and extragalactic scales. And this is why I made such a big deal about having you understand scales earlier on. What kind of scales are we talking here? Well, the variable star standard candle now allows us to measure distances from anywhere from 1 kiloparsec to 30 megaparsecs. 30 million parsecs. Remember, a parsec, 3.26 light years, okay? So we're talking about nearly 100 million light years. This standard candle now gives astronomers a way to measure distances out to about 100 million light years. We never had that before. All right, so what is this pulsation process? Well, again, this is why I wanted you to have an understanding of how a star works in broad basic terms. But now let's look at what happens with a variable star. It goes to something called the Eddington valve. Okay, and yeah, a way to think of it is this. And there's our friend, Sir Arthur Eddington. We talked about him a while back. Recall it was Sir Arthur Eddington who did the experiment with the total solar eclipse that was able to substantiate Einstein's claim that gravity is the curvature of space-time. So yeah, same guy. Okay, this is also known as, it looks like a letter K, but in this case it's actually a Greek letter kappa. Also known as the kappa mechanism. And this kappa mechanism denotes the opacity of a stellar gas. Okay, opacity. If we say something's opaque, that means that light can't go through it. So a tabletop is opaque. A window pane is transparent. That's all we're really talking about here. Okay. Helium is the most active gas in this process. All right. So it's fairly straightforward. The ionization of helium is temperature dependent. Very simply, the higher the temp, the more ionization. And since helium has only 2 electrons, this is pretty straightforward also. Single ionization, 1 electron removed. And that would be lower temp. Double ionization, both electrons removed. Higher temp. Okay. Now we'll pause here and then we'll go on to the step-by-step sequence.